I am Anil Kumar. Welcome to my series on algebra. In this particular video, we'll understand the power of counterexamples to show that the statement is not true. We have 5 examples here. These are very popular questions in test papers, and we'll see the technique of counterexample, which could be summarized in a very simple term as exception to the proposed rule, right? So counterexample provides exception to proposed rule, or you can say definition. So the questions are: show that the following statements are not true with a counterexample. So that's very typical. We'll ask for not true with counterexample. So basically, you have to provide just one example which is good enough to prove that this statement is not true. And that's what we mean by saying exception to the proposed rule, right? So these are the key words. You can always look into these 5 questions, answer them, and then look into my solution. So let's begin by answering the very first question. The question here is, if x is greater than y, then x over y is greater than 1. So the question is, if x is greater than y, in that case, if I divide by y, what happens? X over y is greater than 1. That is what is there. And with the help of a counterexample, we have to show that this is not true. Correct? This is not true. We can identify some values. We can say, well, if y equals to, let us say, -1, correct? And if x is equal to 2, then definitely we have 2 which is greater than -1. However, 2 over -1, is that greater than 1? Right? That is what we're trying to show, right? This is a negative number, and we know this is not true. 2 over 1 is a negative number, which cannot be more than 1. So that is what we mean by saying a counterexample. Perfect. And that means that the statement is false. So show that the following statement is not true. It is false, right? Since we have an example, if y is a negative number, in that case x over y will not be greater than 1. It will be less than 1. Perfect. So that is the concept. Let's take up more examples now. Question number 2 here is, show that the following statements, so I'm using the word statements because we have 5 questions. Show that the following statement is not true with a counterexample. And the statement is sine x equals to square root of 1 minus cos square x. Well, generally, it is true. You know, you normally write like this. You have sine square x plus cos square x equals to 1. And then you say sine square x equals to 1 minus cos square x. And then you may write sine x equals to square root of 1 minus cos square x. But you know clearly that this is not true, right? So we can actually provide a counterexample. For example, we could say let x be equals to, let's say, 270 degrees. Now for 270 degrees, we know sine x, and when I put 270 degrees, which is sine of 270 degrees, it is going to give me a value of -1. Correct? However, the square root, the right hand side, is what? Square root of 1 minus cos square 270 degrees. That is 0, right? So this is 1 minus 0 square root, which is equal to 1, right? And we know minus 1 is not equal to 1, and therefore the statement is false. So clearly in this particular case, we know that for any sine function, it is only positive, you know the cos rule, right? Sine is only positive in quadrant 1 and in quadrant 2. So any angle for x which is between 180 degrees and 360 degrees will have a counterexample. Perfect. So you could give any value. 270 is a very easy number to work with. So that could be a good example. Perfect. Even if you provide one value which says, well, this is not true, that means the statement is not true. Let's take another example, which is question number 3. It says, if x is greater than or equal to square root of x, we are given that x is greater than 0, positive numbers, clear. If we are saying that x is greater than or equal to square root of x. Is it always true? We are saying x is greater than square root of x. Is it true? Well, let's provide a counterexample. What could be the counterexample in this case? Some value of x for which x is lesser than square root of x. You get the idea, right? So the value could be a fraction. So if I have x equals to, let's say, 1 over 4, in that case, square root of x will be square root of 1 over 4, which is half. Now what do you notice here? In this particular case, you know that 1 over 4 is less than half. So the statement is false, and therefore x greater than or equal to square root of x is not true. So that becomes a counterexample. One value sufficient to show that this is not always true. Perfect. And that's how you can do it. Next example here is if x squared equals to y squared. So we are given that if x squared equals to y squared, then x equals to y. So now in this case, what could you do? Well, we can take y value as a negative value, let's say negative 2. In that case, we have an x as 2, right? Let's take x as 2. Now, clearly, x is not equal to y. Since y is negative 2, x is positive 2. However, x square is equal to y square. So again, with one particular example, which is this, we are providing two different values of x and y and showing that x square equals to y square does not imply that x equals to y. Perfect? And that is how, with contradiction with this counterexample, we can show that that is not always true. Now here is the last example, which is if sum of two numbers is a rational number, then at least one of these numbers is a rational number. Now what is a rational number? So when we are saying rational number, it's a number which could be written as p over q, where q is not equal to 0, right? Let me also give you an example of irrational number. Now, irrational number is like square root of 2, correct? Now, the question here is that we need to show with the help of a counterexample that if sum of two numbers is a rational number, then at least one of these numbers is a rational number. That means I have to provide sum of two irrational numbers. As equal to a rational number. Then that becomes a counterexample. Does make sense to you, right? So, well, let's do it. A counterexample could be 1 plus square root 2 let this be one number and the other number be 1 minus square root 2. Now if I add them, what do I get? Square root 2 and plus square root 2 plus and minus, they cancel and we get 2. What we have is a real number here, a rational number, right? Both are real. We have a rational number, but these are irrational numbers. So both irrational. And here we have a rational number. So that's a counterexample. So in general, if in any irrational number we have a conjugate and when we add them up, then the irrational part gets cancelled and you get a real part. And therefore, we can show that this is a counterexample to the statement that sum of two numbers is a rational number. Then, at least one of these numbers is a rational number. Now, both could be irrational as shown in this particular example, and therefore the statement is not true. So I hope with this you get the whole concept of showing that the statements are not true with the help of counterexample. And just one example can say that the statements are not true. And that's the power of this particular example. So I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.